A good day to everyone who's watching. In our lesson 3 today, we're going to talk about the matrices. So we're going to first talk about the order of a matrix. Then we talk about the addition and subtraction. Then others. Here we have a list of some of the examples of matrices. Now, what is inside there? We call them elements or entries. So for me, I would always just like to call them the elements. So we have rows and columns in a matrix. So each element corresponds to a given row and a given column. So when I speak, we always normally begin with the rows, then followed by the columns. So when you look at our matrix A, our element 5 is in the first row, and then first column. First row, first column. So I can call it the element A11 is 5. Element 4 is 2. It is in the second row, then second column. Taking you back of how to identify the rows. The rows run horizontal. They run horizontal, and then the columns run vertical. So when I say row by column, so I mean row, the horizontal and then the vertical. So that is what I mean by rows and columns. So element 3, that is second row, and then the first column. That is my element 3. Rows, then columns. When you go to matrix B, there, our element 1 lies in the second column. That is the first row. So matrix B has only one row. Matrix C has 2 rows and then 3 columns. Now, that takes us to the order of a matrix. Order of a matrix is simply just the number of rows and number of columns in a matrix. This one is number of rows and number of columns a matrix has. So we normally write them, if, for example, if it is a 2 by 2 matrix, I read it as 2 by 2, but when I'm writing, I write this one here. This one does not mean 2 times 2, but it is 2 by 2, order of a matrix. So my matrix A has order 2 by 2. It has 2 rows and 2 columns. Matrix B has order. Here you can first think. It has order how many rows? There are 2, followed by 1 column. Matrix C has order 2 rows and then 3 columns. Matrix D is of order, when you count, that is 1 row, second, third. So that is 3 rows and then also 3 columns. Matrix M, 1, 2, 3, 4 rows, then 1, 2, 3 columns. So it has order 4 by what? 4 by 3. So addition and subtraction of matrices, we are saying we add or subtract corresponding elements. Those matrices that we add or subtract should be having the same order. So suppose I have my matrices A and B right there. If I add or subtract those matrices, I need to add or subtract corresponding elements. So element A corresponds to element E. So if it is the addition or subtraction I'll add or subtract A to E. Then C corresponds to G. That is C plus or minus G. Then B plus or minus F. Then D corresponds to H. So that is D plus or minus H. So just keep into your mind when you are adding, the matrices should be of the same order. This one is 2 by 2, adding to a 2 by 2. 2 by 2, you add to a 2 by 2. Now you cannot add a 2 by 2 to a 3 by 2. This one is impossible because they are not of the same order. So we are going to look at some examples of addition and subtraction of matrices. So work out the following. Example 1, part A, that is we are having 3 matrix, this matrix being added onto that matrix. So the 3 corresponds to 7. So I come here, I add 3 plus 7. Then 10 corresponds to 9. I add 10 plus 9. The negative 1 corresponds to 3. Negative 1 to 3. Then 5 corresponds to negative 6. 5 plus negative 6. Then I can now add, when I add 3 to 7, I get 10. Here I get 19. Here I get positive 2. Then here I get negative 1. The resultant sign here, positive and a negative. Positive and a negative, that one's going to be a negative. That's why we are getting negative 1. So part B, we are having that matrix minus that matrix there. So we said even if it is subtraction, we are going to subtract corresponding elements. So the negative 1 corresponds to 11. The 3 corresponds to 4. So that's 3 minus 4. The 5 corresponds to a 5, that is 5 minus 5. The negative half corresponds to 3 all over 2. So negative half minus 3 all over 2. Then when I subtract here, I'm getting negative 12. When I subtract, I get negative 1. When I subtract, I get 0. So this one here is a fraction. So you can recall how you get with them in senior 1. So I'm having a negative half minus a 3 all over 2. The LCM is the same. The LCM is the LCM of 2 and 2 is a 2. The denominator is the same, so I can just subtract the numerators. So that one I'm getting negative 4 out of 2 and negative 4 out of 2. That one I get negative 2 as the answer. So example 2, given matrices M and N, find M plus N, then find M minus N. So I'm going to first substitute those matrices there. Roman 1, M plus N. I substitute my matrix M from there. That is 1, 1, 4, negative 6, 7, 8, then minus matrix N, which is 1. So the 11, 8, 7, 9, 10, 4. So I'm going to subtract corresponding. So I'm going to add corresponding elements. So 1 corresponds to, this is an addition. So 1 corresponds to 11, 1 plus 11. This 1 corresponds to 8, 1 plus 8. This 4 corresponds to 7, 4 plus 7. This negative 6 corresponds to 9, negative 6 plus 9. 7 corresponds to 10. 8 corresponds to 4. So this one here, when I add, that's going to be 12. When I add here, that's going to be 9. When I add there, that's going to be 11. When I add here, that's going to be positive 3, 17, then 12. So that is my addition of m plus n. So Roman 2, m minus n, I substitute the m, which is 1, 1, 4, negative 6, 7, 8, then minus 11, 8, 7, 9, 10, and 4. So the negative, so the 1 corresponds to 11, so 1 minus 11. This 1 corresponds to 8, 1 minus 8. 4 corresponds to 7, 4 minus 7. Negative 6 corresponds to 9, negative 6 minus 9. 7 corresponds to 10, 7 minus 10. 8 corresponds to 4, 8 minus 4. So when I subtract 1 minus that, it's going to be negative 10. 1 minus 8 is going to be negative 7. 4 minus 7 is going to be negative 3. Negative 6 minus 9 is going to be negative 15. 7 minus 10 is going to be negative 3. 8 minus 4, and that one gives you a positive 4. So this one gives me my matrix M minus matrix N. So we can talk about scalar multiplication of matrices, that is multiplying matrix by scalar. Scalars in physics, you remember them, those are quantities with only size. Then it's going to multiply now the matrix. That scalar multiplying the matrix is that it's going to multiply whatever elements that are inside the what? Inside the matrix. So suppose I'm having my matrix M as that, and then K as the scalar. So Km is going to be equal to K into A, B, C, and D there. And then now the K is going to multiply whichever element, all the elements inside the matrix. So that is K times A, that is K times B, that is K times C, that is K times D. So that's going to be my Km. Numerically, if we have, for example, I have a 2 times my matrix 11, negative 1, 4, 3, like that. This 2 is going to multiply all the elements inside that matrix. So that's going to be equal to 2 times 11, 2 times negative 1, 2 times 4, then 3 times the 2. So you get the multiplication here, 22, multiplication there, negative 2, multiplication here, 8, multiplication there, 6. So that is how we are going to talk about scalar multiplication of matrices. So example 1, given matrices A as that, then B as that, find this and that there. So my Roman 1, I'm having a half A plus a third B. So I need to first of all always first substitute. So this is a half into my matrix A, which is 4, 8 to 16. Then my matrix B plus a third matrix B, which is 9, 3, 21, negative 27. Then when I start multiplying the scalar, we say the scalar is going to multiply whichever element is inside. So this is a half times 4, a half times 8, a half times 2, then a half times 16. Plus a third times 9, a third times 3, a third times 21, then a third times negative 27. So what I get here, I get that one there is a 2. Then this one here is a 4. Then this one here is a 1. Then this one here is 8. Then plus what I get there is a 3. That is a 1. That is a 7. And then negative 9. So from the former examples of addition and subtraction, I think you can complete there. But just in case someone cannot complete, I know there are some people who are ever weak. So 2 plus the 3, that one when I add I get a 5. Then 4 plus a 1, I also get a 5. Then 1 plus 7, that one I get 8. Then 8 plus negative 9, that one I get a negative 1. So this one here, 2b minus the 3a. So I'm going to first substitute my matrices there. 2 matrix B is 9, 3, 21, negative 27. Then minus 3, my matrix A is 4, 8, 2, 16. Then I'm going to first multiply them there. 2 times that. That's going to be 18. 2 times 9, 2 times 3, 2 times 21, 2 times negative 27. Then minus 3 times 4, 8 times 3, 3 times 2, then 3 times 16. So I'm going to add, so I'm going to first get the multiplications here. So this is 18, this one here is 6, this one here is 42, this one here is negative 54, negative 54, then minus, this one here is 12, this one here is 24, this one here is 6. When I multiply that, 10 times 3 is 30, 30 times 6, that is 18, to get 48. Then now I'm going to subtract 18 minus 12. This one here I get 18 minus 12, I get that is a 6. 6 minus negative 20. 6 minus 24, that one I get my negative 18. Then 42 minus 6, that one I get my 36. Then negative 54 minus 48. So minus minus, it's like I'm having a big minus 48. This one here is a 2, that is a 1, then 10. So this one is a negative 102. As simple as that. If matrices P is that and Q is that, find matrix M if 2M plus 3P is equal to 4Q. I'm going to first use that to find my matrix M, which is what that has been asked. So I'm going to first rewrite that. That is 2M plus 3P is equal to 4Q. Then I'm going to substitute these matrices that I know, which are given in the question. This is 2M plus 3. Matrix P is 1, negative 1, 2, 8 is equal to 4 into matrix Q, 4, 1, 3, 4. Then I'm going to multiply these scalars first of all. So this is my 2m plus 3 times that, it's going to be a 3. 3 times that, negative 3, 6, and then 20, 24. Then that one there is 16. Then that is the 4. Then that is the 12. Multiplying, that is the 16. My matrix M that I want is this other side of the equation. So I'm going to take this matrix, the other side. When it crosses equal sign, you need to know that the positive is going to change to a negative. So my 2m now is going to be equal to 16, 4, 12, 16, then minus 3, negative 3, 6, 20 what? 24. Then I'm going to first deal with the other side to find the subtraction of those two matrices there. So this is going to be 2m is equal to 16 minus 3, that's going to be 13. 4 minus 3, that's going to be 7. Then 12 minus 6, that's going to be 6. Then 16 minus 24, that's going to be negative 8. So my 2m is going to be equal to the 13, 7, 6, negative 8. So now 2m is equal to that matrix. The scalar here is the 1. So I'm going to divide both sides by 2 and that way by 2. Then I have my matrix M is equal to a half into 13, 7, 6, negative 8. Now the a half is going to multiply with every element inside there to get 13 all over 2, to get 7 all over 2, to get a 3, then to get a negative 4 as my matrix M.